In this video, we show that limit x tends to 0, sin x to the power 5 minus x to the power 5 divided by 1 minus cos x and sin of x to the power 5 is just equal to minus 5 by 3. Okay, we want to evaluate this limit. We may apply L'Hopital rule. However, that may be a bit difficult. We got x to the power 5, sin x to the power 5, and we need to differentiate the numerator as well as denominator. That may be difficult for us. So what we'll do is, we will apply L'Hopital rule, but after a bit of simplification. We know that limit x tends to 0, sin x by x equal to 1. Limit x tends to 0, sin x by x equal to 1. We want to apply this formula. How can I get sin x by x? We observe that if I divide numerator and denominator by x to the power 5, then I can get sin x by x. Let us do it. Okay, we divide the numerator by x to the power 5. We divide the numerator by x to the power 5. And also the denominator by x to the power 5. Somewhere we want to use the fact that limit x tends to 0, sin x by x equal to 1. We can cancel x to the power 5 out, and we know that limit of product equal to product of limit, and we can evaluate this limit. Okay, we compute this limit separately. We want to use the fact that limit of product equal to product of limit if the limit exists, and this one separately. Okay, this one we know that this is equal to 1. So the given limit simplifies to limit x tends to 0, sin x by x to the power 5 minus 1 divided by 1 minus cos x. Okay, did we simplify? Yes, a bit, but we need to do more. How about this one? Still it appears complicated. However, we know that a to the power 5 minus 1 can be written as a minus 1. So sin x by x minus 1, and then a to the power 4 sin x by x to the power 4, then a cube, so sin x by x to the power 3, then a square sin x by x whole thing square, then a plus sin x by x plus 1. Nice. We copy the limit as it is. Limit x tends to 0 copied. Denominator copied. Divided by 1 minus cos x copied. Okay, once again we apply limit of product equal to product of limit. We can evaluate this limit separately and this one separately. Once again, limit of product equal to product of limit. So we write limit x tends to 0, sin x by x minus 1 divided by 1 minus cos x to be multiplied with limit x tends to 0, sin x by x to the power 4 plus sin x by x to the power 3 plus sin x by x to the power 2 plus sin x by x to the power 1 plus 1. Can we compute this limit? Of course, yes. This is equal to 1 plus 1 plus 1 plus 1 plus 1. How many? 1, 2, 3, 4, 5. Okay, we did simplify a lot. How about this one? We just copied as it is for the time being. Okay, we did copy it And this is just equal to 5. That's a constant, so we don't have to worry about the limit. With limit x tends to 0. How about this expression? Still, that is not that simple. However, we did simplify a lot. What we do is we multiply numerator by x and also the denominator. When we do so, we get sin x minus x divided by the product of 1 minus cos x and x. Just this much, right? Okay, is this of the type 0 by 0 form? As x tends to 0, sin x tends to 0, and sin x minus x tends to 0. So the numerator tends to 0. How about the denominator? As x tends to 0, 1 minus cos x tends to 0, and x also tends to 0. So yes, it is of the type 0 by 0 form, and we apply L'Hopital rule. In applying L'Hopital rule, what we do is we simply differentiate the numerator, which is sin x minus x, and differentiate the denominator, and then compute the limit. If you are able to compute the limit, then you are done. Differentiate the numerator, d dx of sin x minus x, differentiate the denominator, d dx of 1 minus cos x times x, and if you are able to compute the limit, then you are done. Derivative of sin x with respect to x is just cos x. Derivative of x with respect to x is just 1. How about the denominator? Well, we apply product rule. 1 minus cos x. Derivative of x with respect to x is just 1. Plus x times derivative of 1 minus cos x. Derivative of 1 is 0. Derivative of minus cos x is sin x. Are we done? No. We can write 1 minus cos x is 2 sin square x by 2, and then divide the numerator and denominator by x square and evaluate the limit. However, what we will do is we'll simply apply L'Hopital rule once again. As x tends to 0, 1 minus cos x tends to 0. Numerator tends to 0 as x tends to 0. As x tends to 0, 1 minus cos x tends to 0. X sin x also tends to 0. So it is of the type 0 by 0 form. So we differentiate the numerator and also the denominator. We differentiate the numerator, we differentiate the denominator. Okay, 5 we copy as it is. Limit x tends to 0 we copy as it is. How about derivative of cos x, that is minus sin x? Derivative of 1 is just 0. Derivative of 1 is 0. Derivative of minus cos x is sin x. How about derivative of product of x and sin x? We apply product rule. Derivative of x is 1. Sin x copied. Next time x copied, differentiate sin x and get cos x. Okay, as x tends to 0, numerator tends to 0, and denominator also tends to 0, so it is still of the type 0 by 0 form. We can apply L'Hopital rule once again. However, it will be easier if we just divide numerator and denominator by x. Let's do it. We divide numerator by x and also denominator by x. We can cancel x out, and we know that limit x tends to 0 sin x by x is 1. So this limit equal to minus 1 divided by 2 plus 1. And finally, we get the answer minus 5 by 3, and yes, we did it. If you got a different method than this, do write in the comment.